Hello students, I am Alejandro from Victory EIB and CAIE Online Academy. During this video we will be discussing part D of problem number 3 of the 2019 AP Physics 1 exam. Now this problem as well as the entire exam is divided in subparts, so make sure you watch all the videos to have a complete understanding of the concepts involved within this exam. Let's get started. Okay, part D. We're given this information. Another students uses a launcher to consecutively launch several spheres that have the same diameter but different masses, one after another. Each sphere is launched from position A, and we are asked to consider each sphere's launch speed, which is the speed of the sphere at the instant it loses contact with the plate. On the axis below, sketch a graph of launch speed as a function of sphere mass. Okay, we must understand the following. Since all the masses will be launched from the same position, the same amount of elastic potential energy will be stored in the launcher. So the energy, which I will be labeling E, will be given to spheres of different masses. So within this section of the problem, the energy is considered to be constant because every mass will be released from the same position. But the masses are different. So as the mass increases, the square of its velocity must decrease. That means that not only the velocity must decrease, but also it's not decreasing linearly. We are expected to indicate on a graph two things. The first thing is that as the mass gets bigger, the launching speed is reduced. So as we move from left to right on the graph, it should be moving downwards. It's a decreasing graph. The graph should also have its concavity pointing upwards. Our graph should look this way. Sorry. Now, a nice way to visualize this is to understand that if we write an expression for the velocity as a subject of this expression, we'll end up as having something like 2 times E divided its mass equals V squared, or which is the same, we can say that V equals the square root of 2E over the square root of its mass. Now, having a graph in which the launching speed V is represented in the vertical axis and the sphere's mass M is represented in the horizontal axis, it might be convenient to understand that this is mathematically connected to a graph of y over the square root of x, because that's the mathematical operations that are involved within this expression. A constant divided the square root of the variable. And that graph has the same shape. This is a graph. Mathematically, this seen this way. Okay, thanks for watching. Please stay tuned for our next video on the remaining parts of the exam. And also don't forget to register on our website www.victoryonlineacademy.com for a free demo registration. I'll see you on the next video.